Your turn.
Yeah, that's me, yes. Yeah, hi everyone. I'm happy to be here, and I'm happy to stand and not fall because I just slept on this hanging chair out there. Coming over from Japan last night, well, actually it took 1.5 days or 2 or something. I'm still a bit destroyed. I want to talk about web accessibility, and I also have a surprise announcement, not really at the very end. Can you go to the slides?
Yeah, you got your remote. You can go ahead.
Okay. No.
Other way.
Other way. Oh, wow. Oh, good. So, what are the strange things you see on the slides? No. Okay. Come on. Who knows archive? Yes. What was the color of archive until 2 weeks ago? Right. And here is also something. So I hope everyone should be aware we are now an NPO, non-for-profit organization, since 1st of July. So many things changed. One is that the cornel red had to be expunged, so we don't have it anymore. They actually have, I think they have some whatever, registered whatever on this color, so we are not supposed to use it anymore. Yeah. So today what I want to talk about has been mentioned many times today. This is somehow the core of what makes accessible documents accessible when they contain math. We all know there is PDF accessibility 1.7, which is very nice, but completely useless. I show you this in a minute. So I want to talk about MathML a bit after introducing archive, and then what this means for rendering on the web. So it's mostly not about PDF, but we will see a bit. And a very quick start, because it's very hard to get started with this. So what is archive? Most people raise their arms. So sorry, that was a screenshot I took before. There is still the cornel red, right? So we are a preprint server. We just people upload their code and we make PDFs. And nowadays also HTML and publish them. Yeah. So it's the world's oldest since now nearly 30 years. Well, more than 30, 35 already. Well, officially 30 or something. At the moment, we are at 3 million articles. The last years, we were at 2 million, I think we were like 4 years ago, and only in the last 4 years we got 1 million more. I don't comment on some of the quality of these articles. We try to cut on slop, but automatic detection is not easy. It's hard. So, yes?
AI will solve that problem.
Yeah, we explode. Yes, that can happen. So, why is it important? Well, it contains some of the most famous and most important research. First and foremost, many results are first published on archive. Some examples, LLM research, so everything that makes our life hard now was actually first published on archive. But not only this, also in physics, like the gravity wave research, which won the Nobel Prize, or Grisha Perelman only published on his famous theorem on archive. So while many papers actually get published onto a traditional journal, it's often used to ensure prior authorship. This is in traditional mathematics. Where I work in mathematical logic, nobody cares because, the speed is very low, let's put it this way. And not many people work on proof theory for strange logics. But if you look at computer science and LLM research, there is a race, I don't say to the bottom, but there is a race to publish as quickly as possible. And with journals, it often takes months to get the paper out. And so first authorship is very important nowadays. So yeah, not nowadays, always. So archive is often used for this. Yeah. Okay, accessibility. I think we had so many talks about accessibility today. I will not go into details, just a few things about archive and accessibility. So as was already mentioned, there is a legal requirement. Well, it was diluted just before the deadline in the US. Still, it is there to make websites, for example, accessible. And all our websites are conforming to everything standard, but there is a huge problem. What is the main content of archive? It's not the HTML pages showing you the stuff, it's more or less the PDF pages, the PDF papers. And we know PDFs are, sorry to say, by a huge margin not accessible by now. So what we worked on, this is a project that is running already since many years under the R5F. So if you have ever heard this name, this is now incorporated into archive, runs is, and we added HTML versions for the papers. We are working on the backlog, not all papers back to 1991 are converted, but many ours. I always have to get the right button. So I want to give, because it was mentioned today already, many people probably have no idea what this practically means, PDF 1.7 against PDF 2.0 or against HTML version. So here is a screen, here is NVDA reading first a PDF and then an HTML. Please, can you show the video?
You can just hit next slide and we'll go.
Oh, okay, the next slide.
A mathematical formula from the HTML version of an archive paper, as read by the NVDA screen reader.
The absolute value of phi sub 1 is identical to the fraction with numerator 1 and denominator n sub p. The sum from s equals 1 to n sub p of the absolute value of phi open paren x raised to the open paren s close paren power close paren.
The same formula, this time from the PDF.
Right? Everyone who is reasonably fluent with mathematics can close their eyes because, well, we see the formula, it makes it easy, but if you close, you can at least imagine what's going on. Now let's look at what happened with PDF 1.7.
Version of the paper, as read by the NVDA screen reader.
NP P X 1 space bar identical to space N P space left paren X left paren S right paren space dot space left paren
Now we are
2
here, right?
dot 1
We are still
7
having that
right
that
paren
number.
1 space S equals 1.
The same mathematical formula from the
Okay, we can. I mean, it's nice to see, but what NVDA actually can do, you can let it run.
HTML version of the paper,
You can
demonstrating stepping through sections
step
of the
through
formula,
the
with
formula
the
by
NVDA screen reader.
comments on your keyboard and move and let it read out parts of the formula.
Now I'm gonna show how we would move inside the formula by going back and forth.
The absolute value of phi in subscript 1
And then you're gonna go right.
out of subscript is identical to
Now we're gonna move on to the fraction. I'm gonna press the right arrow key again.
the fraction with numerator 1 and denominator n sub p.
Let's say we wanna hear the fraction again. Let's hear it again.
The fraction with numerator 1 and denominator n sub p.
I think
Now
you get the idea. Can I download it? So I think you get the idea. This is a huge difference, right? That's the difference between PDF 1.7, UA 1.7 and 2.0. The one is completely useless with respect to mathematics. There is no, I mean, it reads normal text, that is nice, right? and the math is just completely useless. There's no way anyone can understand what is actually written there. I mean, at least I cannot imagine understanding it. So what's the difference? And the difference is independent of PDF or HTML, right? If you have PDF UA2, you have the same property. If the reader supports it, like with HTML. The point is that the math structure, that the mathematics in the paper is not like in PDF, whatever, before 2. It's not like just blobs of, blobs more or less of ink, pixels that are read out. It has a structure that this is an XML structure of mathematics, and that is what I want to talk a bit about. So, okay, that is something I guess I gave the talk somewhere else. I think everyone here knows what's the problem with mathematics and typesetting is. Yeah. So if you want to render mathematics on the web, so that was our aim at my archive, because one problem is, first, Lua LaTeX and PDF also text PDF is not, was not there when we started there first. And it still requires very modern tooling, which we cannot easily run. I will talk about this tomorrow, but we run TTech 2. I mean, who of you has used TTech 2? I think very few people, yeah. So that's very old stuff. And we still have to run it. So that is not an option, so that's the reason why we convert the text source to HTML. And there, the important part here is that the mathematics part is converted to MathML. And then the rendering on the web is, so what you need are open type fonts. This is the one ingredient, of course. You need MathML. In particular, what is nowadays in most common use, MathML Core. I will talk about this later. And then there are lots of other things like browser implementations. We see huge difference between various browser implementations. Screen reader support, which fortunately is already quite good. I mean, of course, Unicode is also something that needs. Okay, open type math fonts. Probably most of you already know this, so it was introduced by Microsoft back in 2007. Copying what Tech did. Sorry, no, it's not copying, but it's very similar model of describing things if you look at how stuff here is laid out. Yeah. MathML, what is MathML? So it's a W3C standard since ages. There was a MathML 1, 2, and 3 versions. There was one problem with those, they got never implemented. The reason is they were huge, I mean really huge, and no browser no browser implementation wanted to actually implement the whole stuff. Also, the browser implementation were not included in the specification, which made it very hard to actually render the stuff. So this is what now, this is the, I would say, emerging standard, is MathML Core. It's a subset that is sufficient and closely developed in close cooperation with the browser teams. So I personally had good contact with several people from the Chrome team, there's the Firefox team. So that is something where, okay, well, we put off a specification, but we discuss with those who actually have to render it then afterwards, because without this it's not very useful. It also is not only a language. So MathML Core, MathML is not only a language because it is the language and the layout specification. So it gives clear indication that is partly in the open type fonts, they have a lot of details, partly in the rest, how to lay out formulas, right? So, yes, and it's XML based. A very simple example is here. It's noisy, it's the fraction of 1/3, not very complicated, but yeah, for computers and screen readers, this is much more accessible, also much more usable, much more accessible also in some sense. Than something else. So that is the state of MathML. A very quick start. So if you think about you want to write a serious formula in MathML, you don't write it by hand, I guess, right? That's not fun. If you want to do this, there are some tools. There are several tools. One is this website. It's very convenient. You just type in your math, or you copy in your math, and it spits you out your MathML Core. That is nice. Then you can copy it into your HTML page and be done. This is in case you want to set up whatever, math teaching website or whatever that contains math. It's an easy way to go forward. Other way is using LaTeX ML, so the one with the LaTeX ML, I don't know how to pronounce it correctly. You can just feed in whatever mathematical expression there is, and it will give you, with some additional options, you get a bit more details, whatever. Here, a block structure for a formula like x is y to the square, y squared, that comes here. So this is very convenient. As far as I remember, the LaTeX team used LaTeX ML in the initial stages to generate MathML. I'm not sure, I guess this is now history. Font setup, so if you want to actually do this, you also need really the fonts running. It's actually quite easy nowadays. You just throw in a bit of CSS. Oops, that was the wrong one button. So the minimal CSS you have to put in is here for the HTML math paragraph and the MM text, and then a font, a math font that works. For example, Noto Sans Math. If you do this, then, for example, this is a screenshot of a rendering in a browser. And then I just copied it into the PDF. So that's very easy. I wanted to give a lot of examples online, I mean, with my laptop, but then we decided to make it more simple, and I just give some screenshots. You can run locally setup, so I do this also for testing. So, for example, for the archive, we evaluated several math fonts, discussing of which math font we use in our HTML rendering. I'll come to this a bit later. So this, for example, allows for a local copy or for a local copy of Noto Sans if you have the file locally installed. A few examples. These examples come from a very nice website. So this is Fred Wang, who was working on the Chrome implementation and on many other things. He is also doing a lot of testing on OpenType and math fonts. In recent times I have also contributed. He has a page to test various math expressions, and you can choose fonts. Like, for example, here I choose New Computer Modern, which nowadays is also available in OpenType font. A few others is Lucira Bright. You see here, there's also only for local only, because this is, I have it locally on my computer installed, so it can render. TechJaya Pagella, what else do we have? Latin Modern. So there are a lot of different pages. You can also look at how Tech renders against in the browser. That is a very nice view. So this is, whoops, wrong button, no. This is the Stix font. Where you compare here, that is the Stix fonts rendered in my browser against, this is just a pixel image rendered from Tech. And yeah, this is quite strange, I have to say. But there were things, right? So during the time I found several OpenType fonts which just render completely, rubbish. There's one, I think I tried Firefox with one, and it rendered like parentheses of the matrix, like super spaced out, like between every line, like there were 20 lines of empty. So there's still problems. They are being worked on, but it's getting better. There's also a nice page, I think this is from the LaTeX team, as far as I remember. They have set up also a very similar page comparing fonts. So practically all these fonts are available on both sides and give an overview of what is available on the web if you want to use an OpenType math font. The list actually continues here to the right. I guess I cut it off at some point. So if you want to use something on the web, you have to think about which of these fonts use. So for example, at Archive, we have a hard time. For example, our normal text font is a sans serif font, and the mass is still rendered in computer modern. Now you might say this looks ugly. I agree. The problem is the coverage of the open type fonts. With 3 million articles, every possible symbol has probably been used several times. And if we use any other font, we get less coverage. So it's mostly a coverage. It might be possible to stack mass fonts. I'm not sure this is possible. I don't want to try. But yeah, so it would be nice to have a nice font fitting to our, like Vierer mass would fit, for example, to our stuff, but it has also the coverage isn't by far not enough. So this is really depends on what kind of symbols you use. Normal stuff works with all the fonts. I think probably most papers work with all the fonts, but then there are those who use Cyrillic letters in subscripts and I don't know what else. So this is about a bit about MathML. So a few summary stuff. I have more things to say, but anyway. Accessibility for scientific documents is incredibly important. I have to say we have, after introducing the HTML versions of our papers at Archive, there was an incredible positive feedback. Interestingly, not only for those who use a screen reader, for those who is actually necessary. This is not necessarily only blind people, they are highly sensitive, there are all kinds of restrictions you can have, but also from the general community are very positive. The core elements are MathML, especially MathML Core, which we should open type mass fonts, where we should work more, and browser compatibility. The list of open source OTF mass fonts, this is not the complete list. I mean, there are probably many more, but those who do reasonable render are here, as well as the page I showed before from the LaTeX team. And as I said, it's the last, I would say, 1.5 years have brought an incredible improvement in this whole area. Okay, a few thanks to Dejan. Dejan Ginev is one of the authors of LaTeX for lots of input. Fred Wang, with whom also I have worked on the math fonts, and all the many scientists with whom we have worked at Archive to get this out of the door, to help us to make our main content a bit more accessible. Okay, and now for the surprise announcement. So that is, well, it's not that, well, it's for us, it's super important. Today, actually, Dejan released LaTeX Oxide, which is a Rust rewrite of LaTeX. Now you might say, well, Rust, everything needs to be Rust. There is a reason. If we convert Archive to HTML, it takes about a month, or maybe 2 months. That is long, especially if you improve the LaTeX conversion, you have to rerun it again, right? These are costs that are considerable, right? If you rent a machine in the cloud with sufficient computing power and let it run full time for 3 months, that is not cheap. So that was one of the reasons cut cloud conversion costs, because that was a huge part which restricted us to regenerate the HTML pages quickly. It also allows faster submitter previews. So when people submit papers, we don't show them the HTML version, because the HTML version with the Perl, so LaTeX is originally a Perl program. It takes up to 5 minutes, 10 minutes to make a conversion. That is, we don't let authors or submitters wait there. It's also a sustainable issue. Less and less people can write Perl and read Perl, I mean both of that. We are suffering at Archive because all our stuff was written by scientists who wanted to win the obfuscated Perl contest. Many things still run on that, you won't wonder. So So this Rust rewrite started long time ago when Dian was at Osoria, so like 10 years ago. And then he was working with the NIST from 20 to 24. There were about 50,000 lines of handwritten Rust. Most of the tech implementation, emulation, so to say, mass parsing. And that passed only 25% of the test code, which is not enough, of course. Yeah, what happened is that with the help of Claude, I have to say that that changed a lot here. Yes, you wanted to say? No. So with Claude, we came now to, that was released today. Actually, today is the first day. I mean, it was, we used it already since time, but it's the first public release. So it's 10 to 30 times faster than Perl, which brings down the cost of conversion to a day of the archive, of the whole archive, which is a nice speed. In addition, it's one self-contained binary. No super complex setup. It has already the LaTeX dump, everything in the binary itself, including CSS, JS, everything that is supported, necessary. It's supported on all kind of typical, the usual machines. We even managed to get a Windows version somehow out of the door. Yeah, so it is completely test-driven. So the LaTeX ML, the Perl version, has a huge set of tests with I don't know how many. If you have ever tried to install, for example, LaTeX ML on Arch, then it runs automatically the test suite, and this means you can go away for 2 hours or 3 hours because it tests a lot of things. All of these tests succeed now with the Rust rewrite, and in addition, plus a lot of more tests. Public domain and runs. The QR code gives you the link to the GitHub repository that is now public. As a showcase, we also have a editor. So this is not a replacement for Overleaf or whatever. But you can try it out. Type in some arbitrary LaTeX document, and it converts to HTML. There's also a VS Code plugin, all kind of stuff. I think I have here one example from the TIG's rotated triangle. 500 milliseconds for the text to XML conversion for this here. So this is not a PNG import. This is a TIG's rendering that is converted by XML to HTML. So that's quite fast. You can put in whatever you want here. It's anonymous. Everything is deleted afterwards, so you don't worry about this. It's just to show and to stress test the conversion. That's nice. A bit about, as I say, 2 years of development. So this is the Perl code that has increased. And so the current HTML pages on archive are still Perl conversions, but this will change very soon. This is the Rust rewrite. So these lines of code were Claude generated, all of them, with, of course, input and testing. But it worked, was nice. Yeah, just to give you an idea how this works out. So our conversion, both from the Rust version of archive, we have 98% success rate and 75% without warnings and errors. So there we are reasonably sure that the output is correct. And so the rest between 75 and 98, there are warnings. Many of the warnings come from font packages which are not supported, like loading whatever font people load into their PDF document. We are running this now on archive since over a year. We get a lot of feedback. We have a big fat feedback button. We have, I don't know, 5,000 or 6,000 issues that are going down now. To a few items. So the state is that it's working very quickly and very efficiently, and with the new Rust rewrite we hope that we can give the submitter feedback already while submitting, because that is something where we want a good HTML version checked by the author, right? We already show them the PDF, and hope they check it. Well, we know that they not often check it, but we at least give them a chance to check it and the HTML version. And in the future, we might even force that we have a successful HTML conversion to improve just that every paper that is going up on arXiv actually has an HTML version. That is not the case now. There are very few, but still there are. Yeah, that's the state somehow. If you want to contact me, this is my email, also easy to remember. And yeah, thanks for your attention.
Anybody with questions?
My question is trivial, actually. I want to know why H space and M space are reversed on your example slide.
Where?
It's in one of the charts, one of the tables. Back. Stop.
This one here? No.
Hair space
This one here?
and M space. M space.
Ask the LaTeX team. They generate the tables. It's a screenshot for their website, not mine. Sure.
David would never.
I cannot answer, sorry.
I was going to ask a question.
Yeah, but wait, first.
I'm not very familiar with all these things, but I know of one way to go from Markdown, LaTeX through Pandoc, and then to an HTML page that would go through MathJax.
MathJax.
What about this?
MathJax is not good because the screen reader will not read it out correctly. Because MathJax use JavaScript to render the stuff, so this will make it not usable for screen readers.
Okay.
It reads for me though.
It sometimes reads because
Yeah.
it reads what MathJax converts to text somehow, but yeah.
It's kind of slow. That's the other.
Yeah. Two related questions, or maybe just one big question. First, great work converting to HTML, like it. First, is this HTML automatically accessible? Not just math, but everything else. And second, what should we do on LaTeX side? Are there any limitations on the LaTeX side so the output is accessible?
Yeah, very good questions. Yes, the HTML version is accessible. That's no problem. For the PDF, this is one of my plans for the next year to make, we are currently, as you said, we were spin out. We're currently also in the process of moving all of our archive to cloud-based deployments and rewriting stuff. So there are some things on the back burner, but one of the projects I have already code ready is I want to try new submissions to run through automatically to Lua LaTeX with tagging enabled and see, just to get statistics about how many documents fail, how many succeed, and then look into this. So this is one part which I plan to, hopefully deploy within not too far future, that at the same time we produce a normal PDF with the selected compiler. The problem is that people can use XC LaTeX or PDF LaTeX. They can even use LaTeX with DVIPS. I talk about this tomorrow. I want just to try to see what happens if we run every new submission from arXiv through Lua LaTeX with tagging, and then put maybe experimental UA2, maybe with complete broken tagging or whatever, as an experiment on the arXiv website to gather experience and to gather data points about how good the state is. With respect to these, let's say, restricted types of LaTeX documents, right? To be honest, the papers we get at Archive, they aren't like super complicated. Most of them, by far most of them, are not so super complicated LaTeX who write their own super complicated macros to cheat, whatever. Yeah, there are those people, but most of them are not. So I expect, as long as the coverage of packages is sufficiently large, that at least some packages will work. What is the biggest problem? And that is, I mean, not sure if we should discuss this now or tomorrow, is that a lot of publishers' macros, class files, especially physics, APS, they are old. They already break with TechLife 2024. The core rewrite breaks like a lot of class files from publishers. They are not in TechLife. They are just, people have to download it from the publisher's website. And so we see this problem a lot when people compile them at home with 23 and then they just select 25, or the default on Archive, and then it breaks. So that is one of, and there are many, like physics is a huge category and many people use certain classes from publishers. There I see the biggest problem.